All right, well, we're going to move right on in this lesson to factoring quadratics when a does not equal 1. So in number 1, you can see that, that the a value is 3. And in the previous lesson, all of our a values were 1. So it's more common to not have a be 1. So we need to learn how to do it when it is not. We've got to keep in mind that a is assigned to that coefficient on the x squared term. B is the coefficient on the x to the first power term, and then the constant c is labeled as c when we're going through this process. So the first step then is to multiply a and c together. So in this case, when we multiply 3 and negative 8 together, we get negative 24. After we've done that, we move on to step 2, find factors of their product. So I'm going to find factors of negative 24. So I'm going to ignore that negative sign for a moment, and I'm just going to get factors of positive 24. There are quite a few, and 4 and 6. Okay, so we've got quite a few options here for these factors. And so I'm going back to this whole idea again of I want to choose two factors that when I multiply them together I get negative 24. When I add them together, I want to get b again, this positive 10. So that's step 3 over here. Choose the factor pair that adds up to b. So now I got to keep this negative sign in mind as well because I need my 24 to be negative. If I look over here through all these pairs, I can see that my best bet is this 2 and 12 option. If I need my 10 to be positive when I add them together, then that means I need that 2 to be negative. And so 12 plus negative 2 will give me a positive 10. When I multiply them together, I get that negative 24. So this is the pair I want to select. Now we move down to step 4, where it says to rewrite that original equation with the middle term written as a sum of the chosen factor pair. So I'm going to rewrite this original equation right here, keeping everything the same except the middle term of 10x. Now I'm going to rewrite that term as a sum of these two numbers right here. All right, so that means I'm going to rewrite the first term, 3x squared, and I'm going to rewrite that last term, minus 8, exactly as I see them in the original problem. But I'm going to rewrite that 10x as a sum of these two, the 2 and the 12. Okay. All right, and so now I have it all rewritten. We go down to the last step, which says to factor by grouping. This is a skill that we learned in Algebra 1, where you have to take, when you have 4 terms like this, often you have to factor by grouping. And so we can rearrange things in there so that we get the first 2 terms have something in common and the last 2 terms have something in common that can be factored out. If you look here in this equation, these 2 terms right here don't have anything except that x. The x can be factored out, but they don't have anything in common with their coefficients that can be factored out. So there's a possibility then that if we just move things around, because when you're factoring by grouping, you can move things around as you need to. So I'm going to reorder these a little bit. I'm just going to swap those middle terms there. And now I can see that I've got a 3x in common with these two. So I'm going to group those together with parentheses. And now I have a negative 2 in common between these last two. All right, so I've got them grouped out with parentheses, and now I'm going to finish off the factoring by grouping. So when you factor by grouping, you pull out what's common to each of those binomials. So in the first one, I have a 3 and an x that's common. If I factor that out of 3x squared, I end up with just an x left over, and I end up with 4 in that second one. Do the same thing with this binomial. I'm going to take out that negative 2. When I do that, I'll end up with x plus 4 left over. And this is the best scenario if you remember in factoring with grouping. Now we have a binomial that is repeated in each of those terms. So that is now common to both of those. And so I can pull that x plus 4 out. That takes it out of here and out of here. And what I'm left with then is a 3x from the first term and a negative 2 from that second term. And this is your final factored form. All right, let's follow those steps again with number 2. So we're going to multiply our a times our c. So in this case, that will give us negative 6. We're going to find factors of that product of a and c. So our options are 1 and 6. Again, I'm ignoring the negative sign just for a moment. And 2 and 3. All right, so I want to choose now the factor pair that when I multiply them together, I'm going to get negative 6. So one of these is going to have to be negative, one of the terms I choose, and then it needs to add to this positive 5. So again, we can probably pretty quickly see that we're going to need to choose this pair right here. If I need my 5 to be positive, that means I need that 6 to be positive, which means I'm going to make the 1 negative. So they multiply together to give me negative 6. They add together to give me a positive 5. All right, now I'm going to rewrite the original equation. So again, I'm rewriting the original equation, keeping everything the same, except I'm just renaming that 5x as a sum of these two terms I just found. So that positive 6x and that the negative x. Okay, and I'm going to try this. Those could go in either order, as we just showed with number 1. I'm going to see if it works best with this one, this order, and then rewrite here. Okay, so now I can see here that I've got 4 terms, and whenever we have 4 terms in algebra, we often need to factor by grouping. Okay, and so the case is going to be the same here. We can see we've got a 2x in common between these two, and right here we have a negative 1 in common. So this grouping is probably going to work. We probably aren't going to need to switch these middle terms around. So let's go ahead and group them off with our parentheses. And the next step in factoring by grouping is pulling out of each binomial what's common to both of them. So they both have a 2x in this first one, and we end up with an x plus 3 left over. In this second binomial, they have that negative 1 in common. So I'm just going to pull it out. I'm not going to write negative 1. I'm just going to write a negative sign, and that changes the sign inside of here. And again, this is the best scenario when we're factoring by grouping because now we have a term right here. This is a term that has a x plus 3 in parentheses, and then after this negative sign, we have another term with that x plus 3. All right, we've got to keep in mind that we have a 1 right here, okay? Even though we don't really write it, we really actually have a negative 1 there. So I'm going to pull out that x plus 3, pull it out of this term, and when I pull out this term, I'm left with 2x. When I pull out of this term, I'm left with that negative sign, which is really a negative 1. So we'll rewrite both of those terms inside of that next binomial. All right, so moving down to 19. Number 19 and 20 asks to solve the equation. The only difference here is that they actually have set the equation equal to 0, which means we can solve for x. We can actually solve for the roots, where this parabola, where this quadratic equation is going to cross the x-axis. So we're going to get the x-intercepts in the end. We started, though, the same exact way. I mean, the only way to get the intercepts is to put this in intercept form. To go from standard form of a quadratic to intercept form, that's what factoring is doing. All right, so it's the same thing. We're just going to go an extra step to make it a little more usable, the process. So we'll follow the steps. In number 19, we're going to multiply a and c together. We'll get negative 4. We're going to find the factors of the product of that a and c being multiplied together, ignoring that negative sign for a moment. These are my factors. I want it to add to a positive 3 while also multiplying to a negative 4. So the best option here, the only option, actually, is going to be this 1-4 combo. If I want my 3 to be positive, have a positive sign, then I need to put the negative sign on that 1. So they combine together to form 3x. They're going to multiply together to form negative 4. All right, next step, rewrite that original equation. We're keeping everything the same at the beginning and at the end, those first two terms. I'm sorry, that first term and the last term. We're going to keep it set equal to 0 because that's going to allow us to solve the equation. We're just rewriting positive 3x now as positive 4x and a negative x. Now, again, I could have had those reversed. I could have put the negative x first and that 4x after. So you can kind of try both things. That actually might have worked as well in this one. This one you may be able to do both ways. But I'm going to try this, and I'm going to factor by grouping now. So I'm going to group the first two terms, group the second two terms, and I'm going to go ahead and factor out what's common to each of them. In this case, this is what's common. In this case, look, we've got a -1 again. All right, just like in the problem we worked at the top. When we do that, it changes the sign of everything inside, and that's really what we're looking for. We're looking for, when we factor by grouping, where we get a binomial that both of the terms have in common, because the last step in factoring by grouping is pulling that binomial out that is common to both of them. So when I do that, I'm left with this 2x. When I factor it out of here, I'm left with this -1. Now both of those, all of that is set equal to 0. So to finish this problem off, to actually solve for the intercepts, we're just going to set each of those binomials equal to 0 and solve for x. All right, so you would end up with -2 and 1/2. So if you graphed this equation, this is where the graph is going to cross the x-axis at these 2 points. So number 20, first step, multiply a and c together. We'll get -18. Factors of -18, ignoring the negative sign for a moment. All right, now we're going to go back in, say we needed them to add to -3. So the only option that's going to work for that is this 3-6 combo. If I need now I need the 3 to have a negative sign on it, so I'm going to make my 6 negative. That will multiply to -18. It will add to -3. Moving to the next step, rewrite the original equation, keeping a and c the same, as well as keeping it set equal to 0. Rewrite this -3x as a sum of these two factors right here. Okay, now I specifically put them in that order because I recognized that 2 and -6, I would be able to pull out a positive 2. And here I knew the 3 and the -9 would have that 3 in common. Okay, so I intentionally put them in that order. If you don't originally, you're going to find out very quickly that it doesn't factor very well by grouping, and you can just switch those middle terms around. All right, so factor by grouping, because I have 4 terms. So I'm going to group the first 2 off, group the second 2 off. Now I'm going to factor out what's common to both. All right, I'm going to finish that off by taking out that binomial that is common to both of them. When I take it out of here, I end up with 2x. When I take it out of here, I end up with +3. So to finish off the problem, to actually solve for the intercepts, take each of those binomials, set them equal to 0, and solve for x. All right, so if you graphed this parabola, this quadratic, it would cross at +3, and it would also cross at x of -3/2. So those are the solutions to this problem. 29 and 30 ask you to find the zeros of the function by rewriting the function in intercept form. All right, so let's just talk about the directions for a minute. Find the zeros literally means what is x when y is 0. All right, so they could have said it that way. They could have said set the equation equal to 0 and solve for x. They could say find the x-intercepts. So finding the zeros of the function is when y is 0, what is the value of x? Because this should make sense. It's where the parabola, where the quadratic is going to cross the x-axis. So we're looking for the x-intercepts. By rewriting the function in intercept form, well, this just means factor it. All right, when it's in factored form, that's intercept form. That's when we can set both binomials equal to 0, and or a monomial if we have one, which we will in this case. So I'll show you in number 29 what I mean. But you're just setting them equal to 0 and solving for x. All right, so we start this out. It's just as simple as plugging in 0 for y. All right, so now you have an equation that looks like the ones we just did above. Okay, so now we go to putting it into intercept form, means we've got a factor. So now in this equation right here, we only have two terms. And so we can pull out what is common to both of those terms since there's only two of them. This is actually a lot simpler to factor. So what's common between those, the only thing they share is an x. If we pull an x out, we end up with 3x left from the first term and a positive 2 from that second term. And again, that whole thing is going to be set equal to 0. This is as factorable as that is. There isn't anything further that we can do. All right, it's not a trinomial, it's a binomial. So we really are just looking for something that the two of them have in common. So now we're going to take this monomial. This is what I mean. This is just a single x, okay? It's just one term. We're going to set it equal to 0. Okay, so we already know that one of the intercepts is at 0. And then when I set this one equal to 0, we'll get the other intercept, which is at negative 2/3. All right, so finding the zeros of this function meant x of 0 and x of negative 2/3. All right, the y coordinates on each of those will be 0. So if you were trying to write it out as a point, you would say when y is 0, x is 0 is 1 point, and then the other point when y is 0 would be where x is negative 2/3. So this would just be writing out in coordinate point form, which you don't have to do. I just wanted to kind of draw all that together for you. All right, so on number 30, again, we're setting this equal to 0 so that we can find the zeros, meaning find our x when our y is 0. Again, putting it in intercept form, we're going to factor it. So now we have a quadratic. I'm just going to rewrite it out here. We have a quadratic equation that does not have an a of 1. Okay, a does not equal 1. So we're going to follow our steps. We'll take a and multiply it by c. So 12 times negative 15 is going to give us negative 180. Now that looks quite challenging right at the beginning, because now we're supposed to find factors of 180, which there are a number of. However, if you kind of look up here at this positive 8, you can see that there's really only one, and it's pretty obvious what the factors are of negative 180 that are going to give you a positive 8. So if we just exclude the negative sign for a moment, if we take 18 and we multiply it by 10, we'll get 180. If we subtract these two, then we would get a positive 8. Okay, so that means that we want our 10 to be negative so that they multiply up to give us a negative 180, but they'll add up to give that positive 8. Okay, so you might, when you get these large numbers like that, that you have to find factors for, look up at the middle term first and kind of see if there's anything that makes more sense than another pair, and it'll save you some time. All right, but if we're following the steps the same, we're going to rewrite the original equation, keeping the first and last term the same, set it equal to 0, and now I'm just rewriting positive 8x in terms of these two factors right here. Okay, it looks like I probably got my terms in the middle in the right spots because the 12 and the 18 share a 6 that can be pulled out, and the 10 and that 15 share a 5. So I'm probably right. So we're going to go ahead and group them off, pull out what's common to both. All right, and we can see that this is working out really nicely. We've got a binomial in each one that is the same. So I'll factor that out of the first term and get a 6x, factor it out of the second one, and I get that minus 5. All of this equals 0, and then finish it off by setting each binomial equal to 0 and solving for x. Okay, and if I were to graph it, those are my x-intercepts. That's where that parabola would cross the graph.